Okay, so let's talk a little bit about those different phases. Not in detail, I'm going to have a specific class for those different sections, but now I'm going to give you a quick overview, okay? So the first one is hunting. Our goal is a technique to collect samples from different sources that helps to start profiling the malicious threat actors. We need to gather samples from different sources, and we're going to see which are those sources. Okay, the first one is virustotal.com. Virustotal.com has been running probably for more than 10 years, and it is a website which is going to have different antivirus software. So basically, you just upload any malicious piece of malware, and it's going to tell you if it is detected or not by those different antivirus products. But it's also very useful because it has a service which is called hunting or intelligence, which basically you pay them so that you can be able to search for samples. You can even download it from their database so that you can always try to hunt based on YARA rules. We're going to talk about what is that YARA rule term. Okay, so VirusTotal, it is a really good source of information. It was acquired by Google, which is not the best thing, but anyways. And at the end of the day, they will provide you with an API so that you as a developer can even automate the download and searching for samples in that database. Okay? Underground hacking forums. That's another place where you can go and try to grab malicious piece of malware. Okay? Underground hacking forums is not easy and it is risky also. We're going to talk about why it can be risky and what would be the steps that you need to follow if you want to go to those hacking forums. Deep web, which are hidden sites. Normally via Tor is not the only option, but it is a way to search in internet. But the deep web is called that way because it's not indexed by the normal search engines, and therefore you are not going to find those different sites. You need to follow a different route in order to find those sites. We're going to talk about deep web also, which is a place where you can also find real hackers selling exploits or malware. Incident response engagements. If you work for a company which do consultancy for different companies, it's very common that they go into the compromised systems, grab DLLs, grab executables that they don't know what it is. They can send it back to the team, and this is another source for you to have information about a piece of malware. It's another way to hunt. It's not exactly hunting, but it's definitely another way to gather malicious samples. Okay? Honeypots. Honeypots traditionally was, or it is actually as different servers which are vulnerable. Basically, you make those servers vulnerable in internet to attract attackers. The attackers are going to break into your server. They will think it's actually a real corporate organization, and then that way you can monitor their actions. You can learn what they are doing. That's not the intention here, but what we can do with honeypots is we can get that honeypot, put some different ports. For example, if it is a botnet or any malware that connects to a specific port in order to infect the systems, we can wait in that specific port for the malware to connect, grab the sample, and then be able to start analyzing. So we can also use honeypots to gather information or malicious samples from internet. OSINT, which is called open source intelligence, is a very well-known nowadays term, which basically means that you can grab information from different available sources in internet. Okay, we're going to see some examples. Okay, so that was hunting. So the next phase is features extraction. Okay, so you know that now we have all different samples thanks to our hunting strategy. We have all those samples, so what do we need to do with them? The first step is features extraction. So that means that you need, the goal of feature extraction is to identify unique static features in the binaries that help to classify them into a specific malicious group. Okay, so we're going to get static features which can help us to say, okay, based on these features, belongs to this specific malware group. But what are those features? Okay, so The first one is the timestamp. Every Windows binary has a timestamp, which means the date that it was compiled, okay? That can be helpful for us to know when the malware was created. And that is also very helpful to know, like, if this specific piece of malware was created since 2008, that can give you a clue that this specific organized crime is running since 2008, okay? Normally, the attackers doesn't change the timestamp. They can change it all the time if they want, but it is a good way to know when these specific operations start running. And it is a specific feature that you can extract static. What I mean by static is that you don't need to run the malware, you just need to grab it by parsing the executable. Okay? Digital certificates signing malware. That's another very common feature. Normally, a digital certificate can help you to validate that a specific piece of code is coming from a trustworthy company, like Microsoft. For example, Microsoft, they sign their drivers so that we are using it, we know it is a trust and legitimate binary. But the malware authors, they also use these digital certificates either by stealing those certificates so that they can steal it from the creators and sign malware so that when the antivirus or security solutions check the binary and realize it comes with a valid certificate, they won't detect it as malicious. They will think, oh, this is Microsoft binary, so it is not malicious. So I won't detect it. That's one option. A second option is they can also use self-signed certificates, which means it is not validated by a third party, but also can be enough to bypass detection. Or they can use certificates which are already expired and therefore use it to embed it in the binary. All those different ways to do it can help us to extract that specific feature, because we can go and check all the different binaries signed by that specific certificate, and we can get a lot of samples from it. And of course, can help us to classify them. EXIF metadata is basically all the metadata from different files. Can be an executable, can be a DLL, can be a Word document, a PDF. All those different files have metadata, like authors. Sometimes, like RTF exploits, they use the author name, and we can use that author name to classify them. Language also, from Russia, China, MIME types, images, Word documents, all those different features, we can extract them, and again, can help us to start profiling the malicious samples. Import table hash. This is very well known. It was created by Mendiant, which is a very respected company. They used to have a lot of engagements related to compromised companies, and they created this concept of import hash. Okay, so basically the import hash is just, as you might remember, every single executable has an import table, which I'm going to give you an example in the next course. And those different import table is basically all the DLLs being used by the binary. Okay, they grab that list of DLLs and count them, and also take care of the order as they appear in the source code, and then they create a hash of it. That is enough to be able to classify malware. It's not obviously a silver bullet, can have FPs, but it's really useful for classification. Now, the second one is SSDIP. It is a concept also known as fuzzy hash. It is basically able to extract sequence of bytes in the same order from binaries. And that specific sequence of bytes are going to be used as a hash in order to detect samples that can be similar. All these things, as you know, is extracting features to be able to classify the malware. Strings. You can run strings, which is a tool So basically get human readable strings from binaries or any document, and those strings sometimes can have CNC or C2 IPs, which is the malicious server from the attackers, can have mutex, which is a specific name assigned by the malware author so that they can avoid reinfecting machines, but it is also a well-known feature that we can extract the mutex. PDB path, which is basically the directory where that binary was compiled. Custom messages like, oh, I cannot connect to this specific server. So sometimes attackers put specific custom error messages that can also help us to identify specific samples.